Let's take the line integral of the vector field f of xy equals xy minus x for the first component, comma y squared for the second component, over the line or the curve C, where C is the upper half unit circle. So first, for our parametrization, fairly simple parametrization, r of t is cosine of t sine of t, and we'll take t to go between 0 and pi. We'll need in a little second r prime of t, so why don't we just compute r prime of t to be the vector function negative sine of t cosine of t. Now we're going to need to compose f together with r. So taking a look up here at the definition of f, we take x, which is cosine of t, times y, that's sine of t. There's a minus, and then y, which is sine of t. And then the second component has y squared, so that'll turn into sine squared t. Then the line integral over C of vector field f dot d vector function r is integral 0 to pi of the dot product of these two. So we have the dot product of this vector right here with this r prime vector right here. So I guess if you multiply first components, you're going to have to distribute, so you get a negative sine squared t cosine t, and then when you distribute, plus sine squared t, and then for the second components in the dot product, when you multiply, you'll get sine squared t cosine t dt. Looks like these sine squared t cosine t's cancel, so you have integral 0 to pi of sine squared t dt. You can use an identity to write this as 1/2 integral 0 to pi 1 minus cosine 2t dt, and then after substitution you'll get 1/4 integral 0 to 2 pi 1 minus cosine u du, which will be 2 pi over 4, or just pi over 2.